Welcome to Esther Equation Corner. So today we have this right angle to resolve. We have that line AB is equal to 8 to the power of x, line AC is equal to 2 to the power of x, and line BC is equal to 4 to the power of x. Now, from this triangle, angle ABC is equal to 90 degrees. Now, using Pythagoras theorem, we have that AB all squared plus BC all squared is equal to AC all squared. So from here, our AB is 8 to the power of x. So we have 8 to the power of x all squared plus our BC is 4 to the power of x, and our AC is 2 to the power of x. But let's recall, when we have 8 to the power of x further raised to the power of y, this can be written as 8 to the power of x times y. So from here, when we apply this rule, we'll be having that 8 will now be to the power of 2x plus our 4 will be to the power of 2x, or equal to, we have 2 to the power of 2x. So this 8, we can rewrite this 8 as 2 to the power of 3 further raised to the power of 2x plus, and our 4 is 2 to the power of 2 further raised to the power of 2x, or equal to 2 to the power of 2x. But when we have 8 to the power of x further raised to the power of y, we can actually interchange the power to be 8 to the power of y further raised to the power of x. So we can rewrite this as 2 to the power of 2x further raised to the power of 3 plus 2 to the power of 2x further raised to the power of 2, or equal to 2 to the power of 2x. Since we have 2 to the power of 2x, we have 2 to the power of 2x, and we also have it here. Let's name 2 to the power of 2x to be equal to p. It means that this will become p to the power of 3 plus p to the power of 2, or equal to p. So let's move all the variable to the left. We have p cubed plus p squared minus p, or equal to 0. So when we factor out p from here, we have p, open bracket, we have p squared plus p minus 1, or equal to 0. So it simply means that p is equal to 0, and p squared plus p minus 1 is also equal to 0. So let's name this as case 1. We've gotten the first value for p. Let's name this case 1. And let's resolve this quadratic equation. Let a be equal to 1, b equal to 2, and c equal to minus 1. And our p will be the quadratic formula minus b plus or minus the square root of b squared minus 4 times a times c, or over 2 times a. So let's input our values. We have p to be equal to, our b is 1, so this is minus 1 plus or minus, we have 1 to the power of 2 minus 4 times 1 times minus 1, or over 2 times 1. So we have p to be equal to minus 1 plus or minus, we have 1 plus 4, or over 2. So this is p to be equal to minus 1 plus or minus root 5 all over 2. So from here we have that p is equal to minus 1 minus root 5 all over 2, or minus 1 plus root 5 all over 2. So let's name this value of p our case 2, and this will be our case 3. But let's remember that we named our p to be 2 to the power of 2x. So recurring case 1, where we have p to be equal to 0, this simply means that if a to the power of x is greater than 0, then a must be greater than 0. But since 2 to the power of 2x, this implies that our p is 0. This implies that 0 is equal to 2 to the power of 2x. So our case 1 is rejected. So p cannot be 0. For case 2, we have that p is equal to minus 1 minus root 5 over 2. And our p is 2 to the power of 2x to be equal to minus 1 minus root 5 over 2. But this is greater than 0, while this value is less than 0. This negative is less than 0, while this positive is greater than 0. So our case 2 is rejected. So we have case 3, where we have p to be equal to minus 1 plus root 5 over 2. And our p is 2 to the power of 2x, or equal to root 5 minus 1 over 2. So let's take the log of both sides. We have log 2 to the power of 2x, or equal to the log of root 5 minus 1 over 2. So this is 2x times log 2, or equal to the log of root 5 minus 1 over 2. So from here, we can divide both sides by 2 log 2. So we have x to be equal to log root 5 minus 1 over 2, or over 2 log 2. But we have a logarithm rule that says if log a is over log b, then this is the same as log to the base b of a. So applying this logarithm rule here, this will become x to be equal to 1 over 2 log to base 2 of root 5 minus 1 over 2. So when we punch our calculator to resolve this using the calculator, we'll be getting the value of x to be equal to minus 0.347. Thank you for watching Esther Equation Corner. Subscribe and hit the notification bell so you don't miss out on any of our solutions.